Hi everybody. Today I'm going to show you what I've been working on for what seems like about a month, but I really have been working on this project for about a year. I finally just got back to working on it again because I haven't had any time to work on it. I knew exactly what was wrong with it, it's just that I put so much time and effort into it, I just didn't want to look at it anymore. Well, I just sat down for like an hour or two and I got a couple extra parts that would finalize it, and I finished it up in what's worth about 2 extra hours. Basically, what this is, again, it's a water pump sensor, but it detects how much water is in a sump pump, and it warns you by setting off an alarm if the water is too high. So this is really great if the power goes out. So say you're sleeping, the power goes out, you're not going to know. You're just going to continue sleeping. Well, this is actually going to switch to a battery if the power goes out from a wall adapter. It'll switch from the wall adapter to a battery, and it'll continue checking how high the water is. And if the water gets too high, it's going to go off. And in addition, when the power goes off, it will beep to let you know the power is out if you are asleep. If there's other power sensitive devices in your house that need attention. Okay, so if I actually go ahead and turn it on with the switch that's on the side, first it'll show a loading screen. And basically what this loading screen is doing is it's just checking to see if the sensors are connected correctly before it goes and turns on and starts beeping for no good reason. And then it shows you the regular screen, and hopefully you can see it on the camera, but it says current water levels, pump A, pump B, and then the temperature. So pump A is currently at 80%, pump B is at 60%, and the temperature is 75 or 76 degrees, jumping between those. And right now the pumps are just being simulated, so they're actually not correct right now. But if I actually take an object and put it in front of these ultrasonic sensors over here, then it'll change the percentage of how full the pump is until you get too close. If you get too close, it'll start beeping and warn you. So I'll do that again. And here it says warning, pump B has failed, and that's just because that's the first sensor it read as failed, even though these are both next to each other. And then what you can do is hit a button, any of these 4 buttons, and it'll show you alarm disabled, and alarm will enable in blank seconds. So the seconds is, I think it's about 3 minutes worth of seconds, but I forget, I'd have to calculate it again. And to get out of that menu, you just hit the buttons again. Any button will work, and it brings you back to the regular menu. Now you can hit any of these 4 buttons, and it'll bring you to the main menu. So in this main menu, you have 2 main options: pump sensor setup and thermometer setup. Since thermometer setup is the easiest to explain, I'll do that one first. You have 2 options again: calibrate thermometer and select units. So if you calibrate the thermometer, basically what it does is it allows you to add or subtract degrees from the temperature, and that's how you calibrate it. It's not really anything advanced. And the units, it allows you to either select Fahrenheit or Celsius, and it will convert the temperature to the correct degree or the correct unit. And then after you do that, you can hit save, and it'll show that save menu, and it'll bring you back to the main screen. Now you can see that the main screen is actually pretty dark. I do have a variable resistor inside this unit that you can adjust and change the brightness, but right now there's no point in having anything brighter than that because it just wastes power. So if we actually go back into the menu, now we can do the pump sensor setup, and you can do either sensor calibration or set the tank values. For the sensor calibration, you can select either from pump A or pump B. And if you select either pump, it's going to bring you to the same menu. It'll say place an object 1 foot from the sensor, and this just allows this device to figure out how far 1 foot is. And if you do that, it'll just calculate it and store it in the EEPROM of the chip. Now if we go back into the pump sensor menu and do the calibration, I don't want to mess it up, but I can do it right now for pump A, and it will save it. It saved it. We can also set the tank values, and basically it just gives you the option to set the pump depth or set the tank warning level. So for the pump depth, you can select each pump. It's the same menu for each pump. I think the tanks for each pump are about 35 inches, maybe a little more or less. But you can set it more or less, and it'll affect the percentage also. And you can go down to save, and it'll save it in the EEPROM of the chip. And then if we go back into the menu and do set tank values again and set the warning level, you can do the same menu for each pump, set the pump A warning, and it'll set the warning when it gets 4 inches from the sensor, when the water is 4 inches from the sensor. I guess I could set it 2 and test that out for each one. So if I set each one at 2, let's see, set tank values, set warning, set B one, whoop, set warning, set B warning, and for some reason that one is at 14. I don't, oh no it's not, it's actually a mistake. There must be a bug in the code. But then I can go down to save and save it in the EEPROM again. And now it'll require that my hand is at least, or yeah, at least 2 inches from the sensor to go off. And there you go. That's how it works. Now, like I said earlier, what if the power went out? Well, that's pretty important. If the power goes out, this device would be pretty useless if it didn't go on a battery. So in that case, it's still on. It just goes straight to a battery backup, which is a 9-volt battery inside the device, and it'll just continue to run on that until it recognizes that the power went back on. And you may have noticed that it beeped when the power went out, and that's just to let you know that the power did go out. So hopefully that would wake you up in the first place if the power goes out. So maybe there's other power sensitive devices that in your house that require attention. So that's why it would beep. And then when you plug it back in, it beeps again to let you know that the power is back on. And in case you guys were wondering what chip I used, I'm sure a lot of you guys would probably be thinking that I used an Arduino or a basic stamp. Well, I do actually own a basic stamp, but I don't own an Arduino because they're pretty expensive. Instead, I just started out with that basic stamp and I went straight to regular microcontrollers, and I chose the PIC16F1938. And I've got a total of 10 of them right now. They're actually really inexpensive. They're only about $1 a piece. But you can pick them up off microchip.com, and they're a really great deal, specifically these ones, because they have a lot of program space, RAM, EEPROM space, and a lot more options that most microcontrollers don't have to offer for that price. For the program memory, I think it's something around 2048 kilobytes of space, and there are 256 kilobytes of EEPROM space and a lot more options. It's really more than most people are ever going to need. With this program running on this device, this unit right now, it's actually taking up 56% of the program space, and it does take up a fair amount of RAM too, but I really don't worry about the RAM too much because I'm pretty conservative with how much I use up in the program space. And that's about it. For the compiler I use High-Tech C because it uses C. I like C. I would rather have something more like C++, but there's really not much of a difference. It's just that there's more expandability in C++ that most embedded systems don't even need. And that's about it for this device. So thank you guys for watching, and like and subscribe.